Welcome to this video all about quadratic graphs. You can find the PDF with the questions, clues and solutions at mathsupgrade.co.uk. These questions are all non-calculated questions. In the first question, which is worth just 1 mark, we see here Brogan's graph of y equals x squared plus 1. We're asked to write down one thing that's wrong with our graph. So you can see that x squared plus 1, the values where the points are plotted look absolutely fine, but it's just this bottom part here. All of this line should be a nice smooth curve. At the moment it's just a series of straight line segments, so that's what my answer would be here. I just put it's a series of straight line segments rather than a single smooth curve, and that would just be 1 mark. In question 2, we need to complete the table of values for y equals x squared minus x minus 6. So with questions like this, where you've got a complicated equation, always start from the positive values of x, just to give yourself a bit of confidence on these easy ones. So I'm going to start with x equals 1. So when x equals 1, y is going to be equal to 1 squared minus 1 minus 6. So 1 squared minus 1 minus 6 is the same as 1 subtract 1 subtract 6, which would be negative 6. When x is 2, I get 2 squared minus 2 minus 6, which is the same as 4 minus 2 minus 6, which is negative 4. And with x equals 3, it's 3 squared minus 3 minus 6, which would be 9 minus 3 minus 6, which is 0. So the positive values give us negative 6, negative 6, negative 4, 0. So you can see there's potentially a line of symmetry here, since you've got negative 6 repeated here. So this may be negative 4. So we'll just check it by substituting in x equals negative 1 into the equation. So I'd have negative 1 all squared subtract negative 1 subtract 6. Negative 1 all squared is 1. And then these two negatives is equivalent to just adding a positive. So 1 add 1 subtract 6. That's the same as negative 4. So you can see this value is the same as this value. So you can see there's a line of symmetry around here. So this should be 0. You can check it for yourself. That'll give us 2 marks. In the second part of the question, we asked to draw the graph. So make sure you use each set of values. So each column here would be a set of coordinates. So the first one would be negative 3, 6. So negative 3 across, and then 6 up. So small cross there, drawn with a pencil. Next one would be negative 2, 0, so negative 2, and then 0 up, so it's on the axis. Then negative 1, negative 4, negative 1, negative 4, and similarly for the rest of them. So there's the graph I've drawn there, and that would be another 2 marks. Now, the last part of the question asks us to use our graph to find estimates of the solutions to the equation x squared minus x minus 6 equals negative 2. Now if you compare the equation which I was given above, which is here, with this equation, if you write them above one another, you'll notice that they look like this. So here's the equation of the graph I've drawn, and here's what I need to find estimates to the solutions to. So you can see, since x squared minus x minus x equals y, and x squared minus x minus 6 equals negative 2, y must equal negative 2 at that point. So y equals negative 2. So I'm going to draw the line of y equals negative 2. The line of y equals negative 2 would be a horizontal line, and everywhere on this line y equals negative 2. So the values of x vary, but y is always negative 2 at all points. Now I just need to see where this line cuts my curve. Where this line cuts the curve is where x squared minus x minus 6 equals negative 2. So this line equals that line. So here you can see the values are x equals negative 1.5 and x equals 2.5. So there's the solutions to that equation there. Just when you're drawing the curve as well, don't forget you must dip below y equals negative 6 at this point here. You must dip below. Even though it doesn't show it in the table, it's got to be a nice smooth curve, so the curve would never just go straight across like that between these points. Question 3. Here's the graph of y equals x squared minus 2x minus 4. So that's already drawn for us. You've got to be careful here of the different scales. So you can see the x-axis is going across in 2's, whereas the y-axis is going up at half that. You can see that there. We've got to write down estimates for the roots of x squared minus 2x minus 4 equals 0. So compare this equation here with the equation of the graph. If you compare them, you'll notice that you can draw y equals 0. Y equals 0. So if I draw y equals 0, that's where the roots exist. So y equals 0 is actually the x-axis. At every point on that line, that horizontal line there, y equals 0. So I just need to see where the curve coincides with that line there, that axis. And that's at x equals negative 1.2 and x equals 3.2. So there's the roots there, and that's 2 marks. The next part of the question, we need to write down the coordinates of the turning point of y equals x squared minus 2x minus 4. So the turning points of this pre-drawn curve. The turning point is where this point is here, the minimum point here. So you can see there the x coordinate is 1 and the y coordinate is negative 5. So that's the values I put down there, and that question is 3 marks. Question 4. We need to complete this table of values for y equals x squared plus x minus 4. So this table of values, we're going to start by doing this value here, x is 0, because that's going to be the easiest one. Then we'll do the positive values of x, and then we'll substitute in the negative value of x. So with the x equals 0, this will be y equals 0 squared plus 0 minus 4, which gives us negative 4. Then we're going to substitute these ones in now. So x equals 2 gives us 2 squared plus 2 minus 4, which is the same as 4 plus 2 minus 4, which is 2. This one here, 3 squared plus 3 minus 4, which is the same as 12 minus 4, which is 8. So you can see there may be a line of symmetry around this point here. We're now going to substitute in this negative value. That will give us negative 3 squared plus negative 3 minus 4, which is the same as 9 minus 3 minus 4, which is 2. So you can see this indeed is a line of symmetry here. So you'd expect that line of symmetry on the graph as well when I draw it underneath. So there I've drawn it. Just be careful of the scale when you're drawing it, because this scale here goes up in 5s on the y-axis, whereas the x-axis goes up in 1s. That's 2 marks for that. Lastly, we need to estimate a solution to x squared plus x minus 4 equals 0. Again, here's the graph I've drawn, so write the equation of the graph underneath that and you can compare. You can see that the solution to that will be when a y equals 0. So draw y equals 0, which is actually the x-axis here. That's where y equals 0. So where does the curve coincide with the x-axis? Where does it intercept it? And it intercepts it at x equals negative 2.6 and x equals 1.6 for 5 marks. Question 5. We're given the graph of y equals x squared minus 2x minus 3. We need to write down the coordinates of the turning point of the graph. The turning point is just this point here, where the graph starts turning upwards. So it's the minimum point, and that you can see is x equals 1 and y equals negative 4. Part B, we need to use the graph to find the roots of the equation x squared minus 2x minus 3. So I'm just going to write this equation underneath the graph, and you can see if I write that underneath, you can see that y would equal 0. So the roots are going to be where y equals 0. So if I draw y equals 0, which is actually the x-axis, I can see the curve intercepts the x-axis at x equals negative 1 and x equals 3. And there's the roots there, and that's 3 marks for that question. Question 6, we're again given a graph of y equals f of x. We need to write down the coordinates of the turning point of the graph. The turning point is this maximum point here, so you can see it's going to be where x equals 1 and y equals 4. Part B, we need to write down the roots of f of x equals 2. So if you write the equation y equals f of x underneath that, there's y equals f of x, and you compare, you can see y equals 2 is where the roots are going to be. So y equals 2. Here's a line y equals 2 that I've drawn here. So let's just see where the curve crosses y equals 2. And it crosses at x equals negative 0.4 and x equals 2.4. Lastly, we need to write down the value of f of 0.5. Since this is the graph of f of x, you can see f of 0.5 is where x is going to be 0.5. So where does x equal 0.5? Here's x equals 0.5. So where does that cut the curve? It cuts it at 3.75. So the value is going to be 3.75. And that question was 3 marks. On question 7, we're given the graph of y equals f of x. We need to write down the coordinates of the turning point. So the turning point is here. You can see here x equals 1 and y equals negative 3. Next part, we need to write down estimates of the roots of f of x equals 0. So I'm writing the equation underneath. The equation of the graph is y equals f of x. The roots of f of x equals 0 are going to be where y equals 0. So let me draw y equals 0. That's the x-axis here. So wherever the curve intercepts the x-axis, that's where the roots are. So here you can see x equals negative 0.7 and x equals 2.75. In part C, you need to use the graph to find an estimate for f of 1.5. Well, f of 1.5, since this is the graph of f of x, that means x will be 1.5. So x equals 1.5 here, and that's where the function is equal to negative 2.8. So y equals negative 2.8 there, and that's 3 marks for that question. Question 8, I'm told that a particle is moving in a straight line, and I'm given a graph of the distance of the particle from a fixed point O against time in t seconds. So you can see here, since this is distance against time, the greatest distance from that point O is at the top of this curve. So it's the maximum point of this curve which is the greatest distance. I need to use algebra to find that greatest distance. So I need to find S at this point here. That will be the solution to this problem. So what I'm going to do is, first of all, I'm going to find the time at this point here. Okay, so I need to find the time. In other words, I need to find the value of this. I need to find the x coordinate of this point, and then I can find s. Since I know t, I can find s. Okay, so I suspect that this curve is symmetrical, right, around that point. I suspect the line of symmetry here, right, and I need to just find what that point is there. So what I'm going to do, first of all, I'm going to see where the curve cuts the x-axis, that t-axis there. Okay, to find that, essentially I need to put s as being equal to 0. So in this equation here, I'm going to put s as being equal to 0. So I've got 0 equals 80t minus 5t squared. So I'm just going to factorize this. 5 is a common factor of 80 and 5, and so is t. So I've got 5t brackets 16 minus t. Since that equals 0 at this point here, I know that t can either be equal to 0 or t can be equal to 16. If you're not sure on how I've done this, be sure to check out my video on solving quadratics. So t equals 0 and t equals 16. They're the points at which the particle is at no distance from 0. Okay, so that's where the curve cuts the axis. T equals 0, t equals 16. The line of symmetry here, therefore, must be at t equals 8. The midpoint is t equals 8. So I now need to find s when t equals 8. So I'm just going to substitute into this equation t equals 8. That will give me 80 times 8 minus 5 times 8 squared. 8 squared is 64. 80 times 8 is 640. 5 times 64 is 320. Subtract them and I get 320 meters. That question was 4 marks. Question 9. I'm given a sketch of a curve. The equation of the curve is y equals x squared plus ax plus b, where a and b are integers. I'm told the points 0, -5 and 5, 0 lie on the curve. I need to find the coordinates of the turning point of the curve. So I need to find the coordinates of this point here. So what I'm going to do, I'm first of all going to find the value of b. I'm going to find the value of b by substituting these coordinates into this equation. So I know x equals 0 and y equals -5. So x equals 0, y equals -5. If I substitute those in, I get this. If I then follow that through, I get the fact that b equals -5. So b equals -5. So I know that b is -5 now. Now I'm going to substitute these coordinates into the equation. X equals 5, y equals 0. If I substitute those in, and I already know that b is -5, I get 0 equals 20 plus 5a. Subtracting 20 from both sides, and then dividing by 5, I get the fact that a equals -4. So a equals -4. So now I've got the full equation now. I know that y equals x squared, a is -4, so -4x, and b is -5. I need to find the roots. I need to find the roots of this curve. The roots are where it cuts the x-axis. If I find the roots, then I can find the midpoint of those roots, and then I can find the value of y, and therefore the turning point. So the roots, if I factorize this, if you're not sure how to factorize quadratics, be sure to check out my video on this channel. So factorizing this, I'll get x equals -1 and x equals 5. So the midpoint, the middle of -1 and 5 is 2. Okay? The difference between these is 6. The midpoint is going to be halfway between them, which is 2. So x equals 2, I need to find, so the line of symmetry here is where x equals 2. I still need to find the value of y. That's the coordinates of the turning point. So when x equals 2, y equals 2 squared minus 4 times 2 minus 5, which is 4 minus 8 minus 5, which is -9. So the coordinates of the turning point are x equals 2, y equals -9. In question 10, I'm given a sketch of a cross section through the centre of a bowl. The cross section is a shaded region there, and I know that curve, so the edge of the bowl, has got an equation, y equals x squared over 10 minus 3x. X and y are measured in centimetres, and I need to find the depth of the bowl. The depth of the bowl is essentially the y coordinate at this turning point here. So it's that value of y there. So what I'm going to do, I'm first of all going to find where the curve cuts the x-axis, in other words, how wide the bowl is. If I then know how wide the bowl is, since it's symmetrical, I can then find the midpoint. Once I know that value of x, I can then find the value of y by substituting x into the equation. So let's do that now. So to find the roots, I'm putting y equals 0, substituting that into this quadratic. I'm just going to multiply through both sides by 10 just to get rid of this denominator. Then if I factorize, I'll get x equals 0 and x equals 30. So the bowl must be 30 centimeters wide, and that's a sensible number. Since it's got a line of symmetry, as all quadratics do, then the midpoint must be at 15 centimeters. So x equals 15. So when x equals 15, I need to find the value of y. That'll give me the depth. So 15 squared divided by 10 minus 3 times 15 gives me 22.5. It's a negative value here, since that actually makes sense with the curve. But obviously, since the depth can never be negative, so we're just going to put 22.5 centimeters for 4 marks. In question 11, we're given part of the graph of y equals x squared minus 2x plus 3, that curve there. We need to draw a suitable straight line to find estimates for the solution of x squared minus 3x minus 1 equals 0. So I'm just going to write this equation and then write this equation underneath it. And you can see that here. So now I need to find the difference between these. If I find the difference between these, I can then draw a straight line, and then that will give me the estimates of the solution for this. So if I subtract these through, I'll get y on this side, x squared cancel, negative 2x subtract negative 3x is the same as negative 2x add 3x, which is 1x. 3 subtract negative 1 is the same as 3 add 1, which is 4. So y equals x plus 4. So if I draw the line of y equals x plus 4, I'll get the solutions for this equation here. So drawing the line of x plus 4, I've just drawn a little table here. I've got values, just positive values of x, and now I've substituted those into y equals x plus 4. Drawing that line, that purple line there, I can then see where it cuts the curve. So it cuts the curve at x equals negative 0.3 and x equals 3.3. So there's the solutions for that equation, and that's 2 marks. In part B, I'm told that P is the point on the curve where x equals 2. So P is the point on the curve x squared minus 2x plus 3 where x equals 2. So here's x equals 2, that point there. So at that point, I need to find an estimate for the gradient of the curve. So I'm going to do, the gradient is given by drawing a tangent and finding the change in y divided by the change in x. This tangent here can be as long or as short as you want, but better to be longer really to make it more accurate. So I'll try and draw a tangent, okay, and find the y distance, which in my case is 2 units, divided by the x distance, which in my case is 1 unit. And then you can see that you get a value of 2, and that is 5 marks. Be sure to check out my other videos on solving quadratics and factorizing if you struggled with any parts of this booklet.